Okay, hello everybody, what's going on? This is Mohammed, welcome to another video. In this video, we have this problem here, which is basically a rectangle of unknown dimensions. Okay, what is given to us is basically two quarter circles and a semicircle. And since, okay, the three circles are tangent to each other, that's gonna form this triangle, yellow triangle here. So what is given to us is the area of this triangle. So that's the only piece of information that is given to us in this question. By using that, we want to know the dimensions of this rectangle, which in other words, we want to find the radii of these three circles. Because if we're able to calculate for the radii of these three circles, then we would be able to calculate for the dimensions of this rectangle, the width and the length. Good? Okay, so if you're interested, pause this video, give this problem a try, and keep watching this video for a solution. Okay, so how to solve for this problem? The idea, basically, since, okay, the area of this triangle is given to us, okay, so if we are able to calculate, okay, the area of this triangle and equate that with the given area, we should be able to calculate for at least, okay, one of the dimensions, okay, of this, the dimensions of this rectangle, okay? So to be able to do that, we need to think about a way to calculate for the area of this triangle. And I'm thinking about finding the coordinates of these 3 points. If I'm able to express the coordinates of these 3 points in terms of one variable, then I can equate that. I can use, for example, the determinant method of calculating the area of a triangle with the given area, which is 315, the square root of 5 minus 675 divided by 2. And then from that, we can calculate for that unknown variable, okay, that I have used to express the coordinates of this triangle. So that's what I'm gonna do here, okay? Sorry. Okay, so first of all, I will start by connecting this line. Actually, this line wasn't in the original problem, so I have just connected that. Okay, so I will start by connecting this line here, and then I will for the small quarter circle here, I will assume that its radius is a, and that makes this a as well, and the radius of the semicircle is b, so this makes b as well, and this is also a radius, so this is also b, and that makes the width of this rectangle a plus twice b, so that makes this side length here is equal to a plus twice b, and this is the radius of the big circle, so that makes this side here also a plus twice b, and also this side here a plus twice b. Okay, so that makes the width of the rectangle a plus twice b, and the length a plus 2b, which is twice a plus b. Okay, now if you can notice, guys, okay, let's focus our attention to this triangle here. Okay, let me highlight it first. Okay, so let me use this, the blue color here. Okay, so if we focus our attention to this triangle here, okay, so this triangle basically has a width, the length of the base is a plus b, and the length, this is a plus twice b. Okay, so if you pay attention, the length of the base is a plus b, and the length of the perpendicular leg here is twice a plus b. So the height of this triangle is twice the base length, and that makes from that we can calculate for the angle, and let me call that alpha here. Okay, so if this is alpha, I will sketch a right triangle here on the side where this angle is alpha, and as you can notice, the opposite is 2 and the adjacent is 1, so that makes the hypotenuse the square root of 5 using the Pythagorean theorem. Okay, good. Now with this, okay, so the next step is to be able to is to try to find the coordinates of the yellow triangle here. So this point here is basically apparently A, 0. And this point here is 0 and A. So I will assume that this point here, which is unknown to us yet, okay, is R and S. So if we are to express both R and S in terms of A, and then find the area of this yellow triangle and equate that with the given area, we should be able to calculate for A. Calculating for A would help us to calculate for B, okay, as we were gonna see, okay, because there's a relationship between B and A. And to find a relationship between A and B, let's look at this here. So this side here, the hypotenuse of this right triangle, if we multiply that by, if we project that to the base by multiplying by cosine of alpha, then we're going to get A plus B. So we're going to use that to calculate for, or to find the relationship between A and B. So the hypotenuse is basically is basically A plus 3B. Let me erase this. Okay, good. Okay, so A plus 3B. If we multiply this by cosine of alpha, we're going to get the base, which is basically A plus B. And cosine alpha from the right triangle on the side here is basically 1 over the square root of 5. So if we multiply both sides by the square root of 5, we're going to get that A plus 3B is equal to the square root of 5 multiplied by A plus B. Good. Now, from this equation, we can find a relationship between B and A. So if we move, okay, the A on the right-hand side to the left-hand side, so that's going to give us 1 minus the square root of 5. And B is going to give us the square root of 5, okay, minus 3. Okay, so from that, we can get a value for B as a function of A, which is basically 1 minus the square root of 5 divided by the square root of 5 minus 3 multiplied by A, and this can be rewritten as by rationalizing the denominator by multiplying by the square root of 5 plus 3, both the numerator and the denominator. So that's going to give us the square root of 5, and you guys can double check on this, okay, but this is true, of course, divided by 2 multiplied by A. So now we have successfully expressed B as a function of A. So now the next step is to calculate for R and S. And it is easy to notice that R is basically, which is the x coordinate of the point RS. Okay, so R is basically A plus B, which is this length here, which is the base length. We need to subtract from that the projection of the radius B on the base, which is B cosine alpha, which is B divided by the square root of 5. So that's going to give us what? That's going to give us R. So R is nothing but A plus B minus B multiplied by cosine of alpha, which is 1 over the square root of 5. So let's leave it in terms of A and B. Of course, we can go ahead and replace B by A as a function of A, so that R is a function of A only. But we're not going to do that just to save time. Okay, so, but if we can do that, okay, of course we can do that. Yes, let's do it. Okay, I'm not going to go through the details, but if you substitute B here in this equation as the square root of 5 plus 1 over divided by 2, which is this one here, okay, then we can get a final solution for R in terms of A, which is basically equal to the square root of 5 plus 2 divided by the square root of 5 multiplied by A. So that is R in terms of A. We can do the same thing for S. S is basically the vertical projection of B over the base, which is B multiplied by sine of alpha. So sine of alpha is 2 divided by the square root of 5. So it's twice basically b divided by the square root of 5. And we can again substitute b here as a function of a. So that's going to give us this final formula of s in terms of a, which is the square root of 5 plus 1 divided by the square root of 5 multiplied by a. So now we have successfully expressed both r and s in terms of a, and that is the idea here. Basically, we have done almost all the work. Okay, now we want to find the area of the yellow triangle here. Okay, using the coordinates of the triangle, and of course we can use the determinant formula for that, and then equate that with the given area. Okay, so let's do that. Okay, so the area of the yellow triangle is basically equal to half, and then we use the determinant. Okay, the determinant, let me make it straight. Okay, so 0 and a, and then a and 0, that's the second point. And the third point is basically r and s. Of course, r and s are functions of a, so for simplicity, I will keep it r and s. And we put 1 0 as, of course. And then this is going to be equal to what? Half. Oh, let me open a bracket here. Sorry. Let me open a bracket. Okay, so the first one is going to give us 0, of course, here. So this is 0. Okay, so we ignore that. And then negative a multiplied by negative a multiplied by a minus r, which is basically a multiplied by r minus a. And then the last one is going to be as minus r multiplied by 0, which is 0. So as, so plus as. And then we close the brackets. And of course, we know that this is going to be equal to the given area, which is 315, the square root of 5 minus 675 divided by 2. Okay, now of course we need to express both r and s in terms of a, so we have a function of a on the left hand side and a constant term on the right hand side, and from that we can find that a, of course, we can either solve it manually or using any, for example, Wolfram alpha would make it easy for us to calculate for a here. So a is going to be equal to 15 multiplied by the square root of 5 minus 2, and b is going to be equal to half 45 minus 15, the square root of 5, and then close the brackets. And from that, of course, the width and the length of this rectangle is a plus twice b, so a plus twice b is going to be equal to 15, and that is the radius of the big circle, and the height, or let's say the length of the rectangle, is basically equal to twice a plus b. If we substitute the values of a and b in that, we're going to get 15 multiplied by the square root of 5 minus 1, and that is basically the solution to this problem here. Let me highlight that in yellow. So that's basically it. That's the solution to our problem here. I hope you guys have enjoyed this video. If this is your first time here and you want to know more about riddles, logic puzzles, viral math problems, and all types of mathematics related problems, then start now by subscribing to the channel and clicking the bell so you don't miss anything in the future. Thank you for watching, and see you in another video. Thank you.